What, screen capture? No, I got it years ago. Yeah, it's working. I think I tried it. There's like, shut up! There's a free version of it. Shut up! There's a free version of it, but I think it only allows you to record for like 5 minutes or something like that. So then once I was like convinced it did a reasonable job, it's less of a problem now because we used to tone down the frame rate far, so the file size was smaller. But now our upload at the school is pretty fast, so it uploads like a 1.5 gig file at the end of class in a minute or something like that.
Why don't you use OBS?
Huh?
You can use OBS.
Isn't that Windows only?
No, it's not.
Yeah. I don't know. I think the pro version of this cost me $10.
OBS is just free.
Yeah. No, but that's for like game streaming, right?
Well, you can stream from it, but you can also like record your capture. Like,
Yeah. It's probably because that came out after I was already using this, and I've had no reason to research a replacement until it finally breaks. The previous one I used broke with maybe Yosemite or something. Four versions ago, whatever. Actually, it might have been the last cat. What was the last cat? Mountain lion? I think it was. The last Mac OS that was named after a cat. I think it was Mountain Lion. Because I remember when Apple did their keynote announcing the next one, I think their first new one was it Mavericks? I think Mavericks was their first non-cat one. They made a joke at it, it's like, we've been doing this for a while and we're starting to run out of cats. So we thought about, Mac OS, and they put up a picture sea lion, where they had a sea lion like with a beach ball. I think I should have gone with that. That would have been hilarious. Mac OS sea lion and actually had the sea lion beach ball thing.
Just for like one joke of it.
Well, that'd be okay. Actually, that wouldn't have been bad. Kind of a mashup. Okay. So homework assignment was this easy investment calculator.
Yeah.
All right. So the hope is that most of you ran around in circles. So here's the challenge. The challenge is that even though we had object-oriented stuff last semester, and now we're being reintroduced to it, you still solve problems as a programmer very procedurally. So it's hard for you to break out of that shell and start thinking about things in terms of the tools you have in front of you being objects. All right, so the idea here, and what's funny is, and it's supposed to be frustratingly funny for beginning programmers, is that you already think this way as a human being. We've been solving problems in real life with objects for years and years and years and years. But now that you've been learning how to program, and you've kind of started getting into a little bit of a pattern of how most assignments kind of look or something like that. Now we're going back, starting to move towards solving problems like human beings actually solve them using objects, and we're having trouble making that transition. So let's walk through this, and so here's the guy. So I'm going to go ahead and I'm going to open up my contribution. Okay? So we're actually going to implement a majority of this solution at the contribution level. All right, so when we make a contribution, we contribute an amount, right? But we also associate a month number with that contribution. That is, what month was this contribution made? All right? The idea here being is that if we want to run a simulation over some number of months for an investment, we can preload all of our contributions and then just run the simulation rather than having to kind of run the simulation in somewhat real time where we make an initial contribution of $100 and then we apply interest for 12 straight months. Then we make another contribution of $100 and apply interest to the next 12 months, let's say, whatever it is. But we can do that. But in this model, we're able to throw all contributions in at the very beginning and just mark when we were going to make that contribution. So they automatically happen. Go ahead.
I was wondering if, for the Are we supposed to have it compounded interest? Have it be compound interest? Or,
Yeah. Yeah. So we're gonna see this here. So what we're gonna do is because we're going to need this for our amount contributed total, I'm going to keep track of an amount. I'm also going to keep track of one other additional thing. So we're going to keep track of a double. I'm going to call this guy current amount, where current amount starts off as the same thing as amount of the contribution. But the current amount, that's the guy that grows. All right, that way I always have an initial amount. In fact, if we wanted to, we can call this guy initial amount. You didn't have to rename this if you didn't want, but I'll go ahead and call this guy initial amount, and then I'll go ahead and set current amount to that same amount. So at this point, when a contribution is first born, its current amount and its initial amount are the same. We have not applied interest to this guy. All right, but the idea here is we're going to change this over time as interest is applied.
Okay.
That makes sense?
Yeah.
All right, so now in our contribution, what we're going to do is we're going to have a function called apply interest. Now, we can assume that we're applying that amount of interest, that is the 1/12 of 8%, which is what, 0.67%, something like that. Or we can actually, if we want to have more flexibility to do some cool stuff here, we can pass it in. So we can say apply interest, and we can say double interest amount. Let's call it interest percent. All right, and then we'll take in an int month number. All right, so what this guy does is it attempts to apply interest to this contribution in the given month. But we only apply interest if the month that was past us, that is the month that we're trying to apply interest for, is less than, you could say less than or equal to. So as a developer, you can make the decision that am I allowed to contribute $100 this month and also earn the percent for this month? We can say that we contribute on day 1 and the percent is calculated on day 30 at the end of the month. That's fair. Or you can say that we don't start earning interest until the next month. Either one is fine. It's the difference between less than and less than or equal to. So we're going to ask a question here. If the month number that is associated with this contribution, if that guy is, which do we want? Do we want to earn interest our very first month? Or so if it's less than or equal to the month number that was passed in. This guy, this is the month number owned by this contribution that was passed in when this contribution was first built. And I'm going to try to apply interest for a month number of my investment. And we'll see how we're going to use this in a second. And before I apply the interest, I'm going to ask the question. If the month number associated with this contribution came before the month number I might be earning interest for, then I'm going to give myself some interest. So I'll go ahead and say this dot current amount is equal to this dot current amount times. Now, we need to, if we're passing our interest percent in as a percent, it would come in as 0.067. So I'm going to say 1 plus interest percent divided by 100. Something like that. So interest percent divided by 100, if I had 0.67 divided by 100, that gives me 0.067. That's my interest rate. And if I say 1 plus that and I multiply it, growing my rate. So if I had $100, 100 plus 1 plus that guy. That's the math that I'm currently looking at, right? I end up with $101 and almost a cent. Well, not even almost a cent. Almost a cent. That make sense? That's what this math is right here. I'm going to take my current amount, whatever that is. So the very first month, that's $100 by our example. I'm going to multiply it by 1 plus whatever my interest percent was divided by 100. All right, that will give me a number that is larger than this stock current amount. I could have also written it as this stock current amount is equal to this stock current amount plus this stock current amount times interest percent divided by 100, which is going to give you a small amount. So if I did this guy, yeah. So if I did 100 times my interest rate, I'm going to get 67 cents. So actually, so 100 plus, I'm sorry, 100 times 1 plus that. Yeah, it should give me 167 cents. Wasn't it giving me something different before?
Yeah.
101? Oh, I have my parentheses wrong? Yeah, so this is my current amount, 100 times 1 plus my interest percent divided by 100. So I must have had the 1 outside of the parentheses because it was adding 1 to it. Actually, I don't even know what I had. How would I have gotten the 101?
Yeah, I think you had 100 plus 1, not 100 times.
Oh, I had this?
I think so. Yeah.
Oh, yeah, that looks right.
Yeah.
Yeah. So this should be 100. That's my current amount times 1 plus. There's my 1 plus, and then my interest percent divided by 100. All right. So this guy will give me it'll apply interest to this single contribution if this single contribution has a month number that came before or in the current month. All right, and this function is going to return nothing. I'm just going to say contribution, apply interest if you can. All right. So we can even, if we wanted to, we could say try to apply interest if we wanted to call it something very descriptive. That makes sense? All right, so that's what this contribution does. So now inside of our driver, we see we have 2 different investments. So our first investment, we just contribute $1,200 in the very first month, right? Then our second contribution, we contribute 12 contributions, starting with month 1, and we add $100 per month. So in month 1 we add 100, in month 2 we add 100, in month 3 we add 100, so on and so forth. All right. Actually, this is once per year, right? Yeah. Over 12 years we add a contribution. So we start off with month 1. So this is going to be month 1. Then it's going to be month 13. Then it's going to be month 26, right? 13, 25 plus 1, 26. No, 25, month 25. Always the first month of that year. All right, so we're adding 12 to month each time, but we're adding 1 to I each time. So this is going to go through, and this guy right here says make 12 investments. That's what that for loop says. Make 12 investments. This says add a contribution. How much are we adding? 100. In what month are we adding it? The first time through it would be month 1. The second time through would be month 13. Then it will be month 25. so on and so forth. The first month of the next year. So we're making these investments over a 12-year period. All right, that makes sense? So after this, we have two different investments we've created, an investment A and an investment B. And we're going to go through, and here's the total investment time is 156 months. So 156 divided by 12, that gives us 13 years of investments that we're going through. That doesn't mean we make contributions every single year or whatever. In fact, investment A says we're going to throw $1,200 into the account day one and never touch it again. That's what that investment says. The second one says we're going to give it $100 day one and then give it $100 each year after that. Okay? So, total invest time, we want to print out the current value of this after a total invest time, which is going to be 156 months. So we're going to go into our investment. So get current value. What does this guy do? He is going to, I'm going to go ahead and say double, let's see, earning percent is equal to 0.67. That's my percent. All right. And notice here that my investment controls an array list called the contributions. And whenever I add a contribution, I just add something to that array list. So what I'm going to do here is I'm going to go ahead and say for get current value, I'm going to say for int I is equal to 0, I is less than after how many months, I plus plus. So what this guy does is it says go through every single month in this number of months. All right? For each month that we're applying 0.67% interest to, we want to try to give interest to every one of our contributions. For int j is equal to 0, j is less than this dot, the contributions dot size, j plus plus. We'll say this dot, the contributions dot get bucket j, so that's going to get me the current contribution dot try to apply interest. What's my interest rate? Earning percent. And what's my month number? Is I. That make sense? So this guy goes through all the months. After how many? Oh, after how many months? Misspelled it. All right. So this guy goes through all the months and it applies interest to your contributions. Now, at the very end, what do? We go through and we sum up our final value of all our contributions. So double current total is equal to, we'll start off at 0. We'll say for int I is equal to 0. I is less than this dot, the contributions dot size, I plus plus. And we'll say we will grab our current contribution. We will ask that guy for his current amount. And we will add that to our running total. Ultimately, we'll return current total. Go on.
Is there a reason that you initialized current total at the bottom versus at the top?
No, just, yeah, I didn't need it till here, so I just gave it to myself there. He's asking why did I put this here rather than put all my variables at the top of a function? in a really complex function where you might have 20, 30, 40 variables strewn about. Maybe you don't want to have 30 variables listed at the very top, 2/3 of which you may never need or you have no idea what they mean. So sometimes you want your variables kind of dispersed throughout it into the sections where they're being used, something like that. All right, so this will get me my current value. So again, what does my current value do? For all the months that we want to simulate our investment, it goes through. So for each individual month, month 1, month 2, month 3, month 4, so on and so forth. So in this case, for each of the 157 or 56, whatever it was, for each of the 156 months, I want to attempt to apply interest to all of my contributions. So for each month, I'm going to go through all of my contributions. And what am I going to do to each of those contributions? I'm going to try to apply interest to that contribution. How much interest? Whatever my earning percent is, 0.67. And I'm also going to give it the month that I am trying to give it interest. If we go back to our contribution, here's that try to apply interest. We're taking in an interest percent we're going to try to apply, and the month number in which we're trying to apply it. We will only change the value of this contribution if the month that this contribution was made came before or equal to the month number we're trying to apply interest. Otherwise, it will not modify the current amount. Make sense? Go ahead. Question back there?
No, sorry, it was to answer something, but you answered it.
Okay. All right, so does it make sense what this guy's doing? This guy allows me to just ask a contribution. I'm thinking about a contribution as an object. Except in this kind of weird, mentally unstable world, I talk to objects. A lot of people who invest, they talk to their investments. Like, please go up, go up. Right, so I'm gonna look at this contribution. I'm gonna say, look, you try to go up in value. This is how much you're gonna go up in value, and this is when I'm trying to make you go up in value. You decide if I've invested you yet. Make sense? That's what this guy is doing. So I've encapsulated all of that logic inside of a contribution itself. Where now I can just passively ask a contribution, try to increase. If you fit the model, great. If you didn't, if you haven't been made yet, then don't change. You'll start changing later when I pass in a different month. Okay? So now in investment, for every month, I will go through all of my contributions, asking each contribution to try to give itself interest. So what this code here does is it will modify over the number of months I'm simulating my total number of investments, or my total amount of contributions. Because at this point, my contributions should have increased as much as they will ever increase. All right, but we do have one little catch here. So I'm creating my current total. I'm going through all of my contributions here, adding them all up. The current value of each of those contributions. All right, and then I'm returning that current total. Can you give me an example, or this is going to give me the wrong answer? There is one assumption we're making here. It's not a great assumption. Go ahead.
I is equal to the size of the contribution?
Nope. This loop does go through all of our contributions. You got a hint? You got a hunch?
Is it that it has to be in order? The array has to be sorted in order?
No.
Does it have to deal with the fact that if you try to input 0, it's that would affect it?
So you're making a contribution every month?
No, I mean, it doesn't necessarily require a contribution every month. Let me ask you this. Here, I'll give you a hint, a code-based hint.
Okay. Sure.
So we're going to go to driver here. What if I change that to 10?
Oh,
Oh.
it's because it's going, yeah.
It's going to sum up all of my contributions that already exist, right? How many of my contributions in investment B happened before month 10? One of them, right?
Right.
The first one happened in month 1. The second one happened in month 13, then month 25, so on and so forth. So only one of my contributions in month B actually occurred on or before month 10. Now, if I go back into investment here, all of this up here is fine. That logic does what it's supposed to do. It's going to say, I'm going to go through all the contributions, and I'm only going to increase your value if you were made in that investment month or before. But what does this guy say? It says, sum up the current value of all contributions. And what is the current value of a contribution? When it's first born, the current value of a contribution is the initial value of that contribution. So all of those $100 investments that I'm making in the future are getting included in this sum. Even though they've never increased in value, I defaulted their original value to be 100 or whatever the initial investment was. So what I can do here, again, I can move my logic into current amount or into a contribution. And I can say public double get current amount. And I'm going to say given month. So I'm really creating my variable or my methods with verbose method names here. So I'm going to return the current amount only if this month number was less than, well, only if this month number is less than or equal to this month number. So if this dot month number is less than or equal to month, if that's a true statement, then I'll return this dot current amount. Else, return 0. This guy does not have a current value if the month I'm requesting its current value for did not occur. Or if this contribution had not occurred by that month. So I'm saying if I'm coming from a contributions perspective, is the month that I was made, did it come before or on the month they're asking for my current value? If it did, no problem. I'll just give him my current amount, which may or may not have increased or whatever, doesn't matter, but we know it had a baseline value of whatever the initial investment was. But if they're asking me for example, if they're asking me for a month 10 is the month that they're asking my this contribution for his current amount, and he's not made until month 13, he's going to say, I was born month 13. Is 13 less than or equal to 10? It's not. I don't have a current value. I don't actually exist yet. That make sense?
Smart.
So now what we can do is inside of investment, when we get our current total, rather than just directly accessing the current amount, we're going to call our get current amount given month. And we're going to pass it the final month of our simulation. This code up here is fine. We're going to try to apply interest to every single contribution, and it'll apply interest to only the ones that it made sense for, right? But this guy down here, I want to get a total amount of money, and I don't want to mistakenly tack on amounts for contributions that weren't actually made yet. By our current example of the 156 months, all of our contributions had been made. So the code would not have broken just because the example we were using took into consideration what our contributions. It was a reasonable question for us to ask. Like, look, you've made investments over these 13 years, and now I want you to tell me what they're worth. So we know as a human being that all these contributions had been made prior to us calling this function. But this code protects us from us asking, hey, during month 17, what's our investment worth? Make sense? So now we're going to say we want to get our current total, and we're going to add to it the current amount given the month. What month? Whatever the final month of our investment we're simulating is. And it'll give us zeros if a contribution hadn't been made by that point. And then finally, we'll return that current total. Make sense? All right. Now, we can go into total contributions. And this guy is just going to go through and do something very similar. But we want to, here, we'll just write a pretty similar logic here. We'll say double current contributions is equal to 0. We'll say for int I is equal to 0, I is less than this dot the contributions dot size I plus plus. And now we're going to say current contributions plus equals this dot the contributions dot get bucket I. Now we want to ask that contribution for his initial value given the month. Because getting total contribution for an investment, this is going to be taking into consideration, well, actually, so get current value is taking in a number of months. Total contributions, if we just leave it alone like this, then we can just add them all up. So if we don't pass in a number of months here, we're just saying, hey, how much total did you put into this guy, whether interest has been applied or not? So I guess the way this guy is written for total contributions, we could just say dot initial amount and then return that guy. But we could have a version of get total contributions that takes in a month number and says how much has been contributed by that month. Does that make sense? All right, so if we come into this guy, here's our driver. We're going to do our, what do we have, 156 here?
Yeah.
Oh, it's because you guys stand and put an L.
So my first investment, this is A, where I just put in $1,200 day one and let it grow, is now worth $3,378 after 13 years. My second investment, where I put in $100 per month, is now worth $2,258 at the end of 13 years. Those numbers look right? All right. Now, you would have gotten these numbers even if you didn't put in our special logic for, hey, don't give the current value if it's outside of the month, because our example happened to be compatible with that not being a problem, right? But if you had changed this to 10 months, you would have gotten much bigger numbers than this. Right? Because you would have taken your other $1,100 investments and counted those as part of. It's like, look, I know I didn't make this until year 11, but I want you to count it in year 1. Just trust me on this. I'm good for the money. That makes sense? Okay, so I won't take off for that, but do we all understand why we need to put that little check in there? Okay, so now we can kind of play around with this, and we can give it 156 and look at the numbers we get here. So remember the whole goal here. We're trying to figure out whether Pastor Smith made the right call by paying $100 a month, or did he make the wrong call? So this first investment is kind of meaningless in this example, because this first investment says that he put $1,200 away day 1. So that means we're presuming 13 years ago he had $1,200, right? Because he was willing, I think he said it was $1,300, right? But we knew he had a choice. He either had to pay $1,300 day 1, he gets a lifetime membership, or he could pay $100 day 1, and he's good for the year. And then next year is to pay $100. The next year is to pay $100. The next year is to pay $100. So on and so forth, right? So that means we're presuming he had $1,300 day 1 and gave them $100 and invested the rest, the other $1,200 on day 1, with the hope of that investment paying for a lifetime of $100 a month contributions. Or $100 a year contribution, sorry. That make sense? All right. So that means that every year we have to debit our account for that $100 because we're living off this investment. All right. Or in Pastor Smith's case, he's paying for his alumni association fee off of this investment. He's going to say, look, rather than giving this place my $1,300 day 1, I'll give them the $100 they demand. I'm going to put the other $1,200 into an account, and then every single year, I'll pull $100 out of that, and let's see if my investment keeps up. Right? Because at the end of 13 years, if we're far enough ahead that we can just keep feeding off this thing for perpetuity, we're great. All right, so we now need to build into our investment a way of debiting it, right? Because every single 12 months, we want to debit this guy. So we're going to go into our investment, and we have a add contribution, and now we need to do a make. A remove amount or something like that. Okay, so we're going to say void debit account, and we'll take in a double dollar amount. And we'll probably also go ahead and take in a month that we're debiting that in, since we're kind of operating off this long-term investment where we're going to do all of our credits and debits at the very beginning, and then run the simulation and see how it goes. Actually, now that we're doing it this way, we could probably make the argument of running the simulation on a month-to-month basis. What's going to be the easiest for us to... Let's write debit account. So debit account is going to take in a month in which we're going to do this debit. All right. And what we're going to do is we're going to have a collection of debits that are going to have to happen on an account. So any given month when we are getting ready to do when we're getting ready to give interest, we would probably need to go through and apply any debits that should happen. That makes sense? So we'll build up a collection of debits. All right, so now what's a debit? If a contribution is an initial amount, a current amount, and a month number, a debit is going to have a month number and it's going to have an amount to be debited. Correct? That's what a debit is. So contributions grow. What do debits do? Debits go down. All right, these guys go down. All right, so we're going to go ahead and we're going to, debits are the things we don't want. We always want our account to go up.
Yeah.
And then we want to use somebody else's money for everything, for everything else. All right, so we're going to come in here. We're going to say new class. We're going to add another object here. We're going to add a debit object. All right. So what's a debit object going to do for us? Well, we're going to keep track of some stuff. We're going to keep track of a double amount and an int month. So this is how much I'm going to debit, and this is when I'm going to debit it. Make sense? So, let's go with this. So I'm going to go ahead and we're going to say public debit. This guy will take in a double amount and an int month. We'll say this dot amount is equal to amount. This dot month is equal to month. All right, and that's all. And that's all a debit will be. Okay, so this is a little data structure that is allowing us to hold some information about an amount of money that is going to be coming out of our investment on a certain month. All right, make sense? All right. So now in our investment, we want to debit the account a dollar amount in a given month. So what are we going to do? We're going to add to, so this guy currently has an array list of contributions. We now want to create an array list of debit objects. All right, so an investment now keeps track of all contributions and all debits that are going to occur, right? Okay, so now we're going to go into debit account, and whenever we debit our account, we're going to add something to the debits. So we're going to say this dot, and this guy's adding a contribution. Yeah, I'm going to do debit account slightly differently just to show you an alternative way you could have done this. Because out here in driver, notice how we had to build our new contribution. You had to know about contribution objects out here, as opposed to just saying, hey, here's the amount I'm contributing and this is when I'm contributing it. So we could have handed add contribution 2 pieces of information and then let him behind the scenes go ahead and build the object for us. Ultimately, the object gets built. Either way, we can either build it outside and then pass the object into add contribution, or we can pass in the 2 pieces that a contribution needs to be built into add contribution and then let the investment itself construct our contribution and add it. So I'll do the alternative for debit just so we can see the 2 options. One is not necessarily better or worse than the other. It ultimately comes down to what kind of organization you want to have here. Since we're the programmer and we're writing this part of it too, we already know about contributions. We're going to know about debits. So using those objects directly is not a problem. All right, but I will use in investment, we'll go ahead and take in the dollar amount and the month, and we'll say this dot, the debits, dot add a new debit, passing it dollar amount and the month. That make sense? All right, so now we will go back to our driver. All right, so now this first investment, investment A, we're putting $1,200 in on day one because we're spending $100 per month, or $100 per year rather. Okay, so I'm going to rename these guys a little bit. So we're going to call this guy Smith year to year. Go ahead.
Will the debit account kind of act as the constructor behind the scenes, and then we'll make like a make payment method?
Well, we can, but we're actually going to just automate it in our simulation. But we could. We're going to, before we apply any interest, we're going to check if any debits needed to happen that month. So we're going to go through our debits and check that. All right, so, but we're going to just rename our investments here to kind of keep track of what we're doing. So this year-to-year payment version says we're going to go ahead and we're going to contribute. Oh, actually, I'll show you something interesting here. So it starts off as an investment called A. Now I want to name it something more meaningful because this guy is representative of the investment that Pastor Smith maybe made day one, right? Of his, when he made that call. Do I give my alumni association $1,300 and have a lifetime membership, or do I give them $100 and then take the other $1,200 and invest it, knowing that I'm going to pull $100 out of that every single month? Will it be able to keep up? Okay, so we might not want to call that A. So I'm going to highlight this. I'm going to right click, and we should have a thing in here called refactor. And I'm going to go to rename. And we're going to call this guy Smith year to year. And you see how it updated it in all the places I used it? So I can directly rename this guy. Or I can refactor it. And have it automatically change it in all the places I used it. All right, where this second investment really doesn't even need to exist anymore, right? Because what we're really asking, I mean, we know that he can just say, I'm not going to make an investment. I'm going to just give the entire $1,300 up front and I have a lifetime of it. He can create other investments, right? And do whatever, but it's not pertinent to this. He's basically on a lifelong battle now of having to pay $100 per month or $100 per year forever for his alumni association. And he, in his sermon, suggested this might have been a mistake, right? He said, hey, this was a mistake. If 13 years ago, or if in the beginning, I had just paid it off for a lifetime, by now I wouldn't have to give them money every month, every year. All right, so I'm going to go ahead and get rid of investment B. We're no longer going to add contributions in investment B. Go ahead.
Wait, so how did you replace the A, all the A's with the Smith?
Highlight it, right click,
Right click,
go to refactor,
refactor.
and then rename.
I only have move on here.
I don't know what to tell you.
Well, fair.
Does everybody else have a rename? Who's trying it? So make sure you highlight it. Got to highlight the variable.
Yeah, that's what I'm doing.
Yeah, I don't know what to tell you. There should be a refactor rename. All right. Now, we're no longer even going to work with our B investment. The question we're trying to answer here is whether or not investing $1,200 back then will give you money to pay for a lifetime of alumni association with some extra change to do with what you want, right? And see how that translates over time. So what we're doing here is we're going to say that let's just do this for 12 years initially, right? But instead of us adding contributions every 12 years or every year, we're instead going to start with we're going to do month 13 will be our first debit because we presumably paid $100 day one and then invested the other $1,200, right? So we'll make our first debit in month 13. And we're going to go ahead and make 12 debits. So we're going to say Smith year to year dot debit account $100 in month. And then we'll add 12 to that each time through. So this will make 12 $100 debits over the life of the investment. Or over the 13 years, right? We're hoping we still have a balance at the end of that time. So we want to see if this investment keeps up. Okay. So total invest time is still going to be this. We no longer have B. But now what we need to do is when we do get current value, we have to go through and for a given month, make all debits. Okay? So we're going to go into our investment. And we're going to go ahead and I'm just going to create a separate function here. Just to kind of keep things compartmentalized a little bit. And I'm going to have a function that's not going to return anything. And it's going to called execute debits int month. Like that. All right, and what we want to do is we want to go through all of our debits, and any debit that is that needs to be made, we're going to go ahead and subtract that from our current contributions. Does that make sense? All right, so first thing we need to do is we need to go through all of our debits. Now, one assumption we're going to make here initially is that, just for the sake of argument here, that we never make more than one debit in a month, even though that's not necessarily reality. But in our current version of this, we'll update it in a few minutes, but in our current version of this, we're going to say, we know for a fact that there will only ever be at most one debit in our array list of debits for this month. That make sense? Otherwise, we might debit our account 2, 3, 4 times a month, in which case we need to handle that a little differently. All right. So, but we'll assume there's only one ever for a given month, which will support what we're trying to do right now. So what we need to do for execute debit is we need to go through for the current month and find, is there a debit for this month? All right. So I'm going to go ahead and create a debit called temp. I'm going to start that guy equal to nothing. Then I'm going to say for int I, I'll actually show you something interesting here. Does the book show you for each loops?
I think so.
This should show you something that looks like that.
Yeah.
So, actually this is fine. So what this says is if I don't need that, so this is equivalent to me saying for int I is equal to 0, I is less than this dot the debits. dot size I plus plus, and then saying debit D is equal to this dot the debits dot get I. These two for loops do the same thing. So the advantage of this first one is I don't actually have to extract a value. The for each loop says each time through this variable D will be equal to the next element in debits. The disadvantage of the second one is I do not have a variable I that tells me where in my array list I currently am. So it's convenient for going through every element in a collection, but we've given up our information about where in the list we are. We don't always need to know where we are. We just might want to say, I want to go through all of these and do stuff, right? Which is pretty common. So this would have helped us reduce the number of I's and J's and things like that we had in our other loop. So I'll go ahead and use this one here. All right, so I'm going to go through all my debits, and I'm going to ask a question. If I want to know if the debit I'm currently looking at should happen in this month. So if D dot month is equal to the month in question, we'll go ahead and say temp is equal to D, and then we'll break. Get out of the loop. We are making the assumption that we will only find one debit for a month. That's not the best assumption in the world. In fact, I'm going to throw that up here. Make the assumption that at most there is one debit per month. That's not the most accurate assumption, but it's the assumption we're going with for right now. All right. So I'm going to go through all my debits. If I happen to stumble upon a debit that's associated with our current month, then I'm going to go ahead and remember that debit in my variable temp and then break out of this loop. I have found my one. Once we're after this loop, I can ask a question. If temp is not equal to null, that means I had found a debit. Now I need to take money out of the investment. That make sense? So if temp is not equal to null, if I actually have a value for temp, I need to now remove money from my investment. Now, how is money stored in my investment currently? If I looked inside the box called investment, what am I going to find in there that equals the money I currently have? I have two kinds. Go ahead.
Amounts and array list elements.
Okay. Are they actually amounts? What kind of? I'll see two little array lists. They might be organized. Two little organized cubbies in there. Those cubbies have what inside them? Is it an amount or is it it's a contribution? Okay. So I got these little tiny boxes inside the bigger box. So I got a bunch of contributions sitting here. Maybe contributions are colored blue. Or they're colored maybe green. And debits are colored red. Makes some sense. All right. So I have to reach in and look at the green contributions because those are going to be the source information for my debits. Correct? I need to go through and reduce or remove contributions up to the point that I have taken back the money that is associated with this debit. Okay? But I need to make sure that those contributions were available at the time of that they were available at the time of this month. You know, because that contribution might not happen for another 20 months, in which case I can't take money away from it yet. That make sense? So before I go any farther here, what I'm going to do is I'm going to go into my contribution. And I'm going to create a function here. And this guy is going to be called attempt to debit amount. And this guy is going to take a double amount and an int month. And this will return the amount of money left after any debit occurs. Make sense? So I will try to debit this contribution. Let's say I'm trying to get rid of $100 and this contribution is currently worth $400. I'll say, oh, I can take 100 away from 400, and I was able to take your entire amount away. You'll return so you'll reduce current amount by whatever amount was. So if my current amount is 400 and the amount I'm trying to debit is 100, I can reduce 400 by 100, giving me 300, and then I'll return 0. The amount that is still owed for this debit, because I was able to handle the entire thing in this contribution. Okay? So now I can go ahead and ask the question. I need to know, can I even utilize this contribution in this month? If this dot month number is less than or equal to month, is it available now? Or is this some future contribution? If it's available now, then I can try to take some money away from it. All right. Now, I can take some amount of money away, possibly. So what I can do is I can say, double what's left is equal to this dot current amount minus amount. All right. Now, if what's left is still a positive number, then that means I had enough money in this contribution to do the whole rigmarole, right? So if what's left is greater than 0, so if after taking the amount of this, if after determining that my contribution can be accessed for a debit, it already existed for this month, after taking the amount associated with that contribution, the current amount after any interest that's been applied, whatever, and subtracting for it the amount I'm trying to debit, I can look at that money. So in my example of $400 being current value and me trying to debit 100, 400 minus 100 would give me 300 inside of what's left. So if what's left is greater than 0, I would say this dot current amount is equal to what's left. And I'll return a 0 for what is owed. I fully debited the amount that you needed me to debit. So this is adjust the current amount, return 0 for what is still owed to fulfill debit. I fully fulfilled the debit with this one contribution. Make sense? Else, if what's left is 0 or less, all right, Then I'm going to set this dot current amount equal to 0. I don't have money left. Okay? I have drained this contribution down to 0 or well, to 0. And then I'm going to return what's left times -1. So if I had $100 in my current value and I was trying to debit $400, 100 minus 400 is -$300. I have not fulfilled this debit yet. Okay? So I'm going to say my current amount 0. I have drained this contribution. All right? And then I'll go ahead and say you still owe -300 times -1 is 300. That's how much is still owed on this debit. I'm going to have to go someplace else to get the rest. All right, that makes sense? All right, so we'll return what's left. One way or another, we are either, this says we have enough money to fully fulfill. This guy says we partially fulfilled the debit. Does fulfill have 1 or 2 L's or 5 L's? There's 2 L's here?
Or no, one. Oh, one there.
Yeah, that's right. All right, so. All right, so what we partially fulfilled the debit. Make sense? And we'll return a -1. Now, this is only if we could even debit this contribution. Because this contribution might not have existed yet. So we will return the entire amount. We could not participate in this debit, so return total balance. That make sense? All right, so this is to attempt to debit an amount on a particular contribution. This guy right here, execute debits, says we have found a debit if temp is not equal to null. So now we need to take money out of our investment, contributions in our investment, until we have got rid of all that money. Print out of money if we run dry. Something like that. All right. So that's what execute debits will do. In get current value, we're going to say execute debits for, sorry, it's not right there. It's for I. So this will be execute debits for the current month. So we'll call our execute debits here. Then we'll add any sort of interest we have after we've taken money away. And then we'll get our total amount. So for your homework, implement this so that debits are correctly taken. That makes sense? So when all is said and done, we should be able to paint a picture of when Pastor Smith runs out of money, or if he made the right call of investing $1,200 day one and paying $100 a year. That makes sense? All right, so I'll push this up to GitHub. I actually have mine set up a little bit nicer, so if you just want to watch for a second as you're packing up. My Git desktop is set up to, I have it set up in my repository. I have my repository set up in my Eclipse folder. So notice it already sees the changes here. So I'll just say updated for homework, commit that to master.
We have to do it a little bit differently, right?
Oh, what's this
You've
guy?
already- So if you've already formed your original version, this up-
And then I'll push to origin.
Yeah, you're supposed to do it.
So the source files for your Eclipse
Yeah.
project are the same source files as your GitHub logo?
Yeah, I don't have to copy it.
Like project. I mean, I guess for
It's you actually create your Git repository in the directory where your source folder lives.
We don't have to create a new repository.
No, it's not bad. I wanted to keep it very separate because, like I said, we're going to be moving towards Android Studio. If you didn't notice, just real quick, I know people already walked out of the room. There is a midterm exam that is up. That is due by Thursday at midnight. It went live right at the end of class right now. Or maybe it goes live at noon, something like that. You have the full, I think some of you, I think I give you like 2 hours to take it or something like that, which is more than double the time. You have to do it in one sitting. So it's on Blackboard. We won't have it in class. You go onto Blackboard, you take the exam. Just make sure you have enough time set aside to do it. Submit this Thursday by midnight.
This Thursday.
It's between now and this Thursday at midnight. Come up with an hour. Well, the exam is designed to take an hour.
Do we have study guide or anything?
No study guide.
What?
Wait, so is this homework not due by this Thursday?
That's a good point. I'll make this homework due on Tuesday.
Oh,
I was about to be like, whoa. Alright, well, it's time for us to go to the cat.
I'll put up a little information on Slack over what you should study for the exam, but it's only up through what we've done so far. It's about, I think, 3 programming questions. The rest of it is vocabulary or reading code.
do you want to watch?
Let me just get this uploaded real quick.